Hello students, I Ajay Gupta from Mechanical Engineering Department welcome you back to the zone of learning. Today you will learn about an important machining process from non-conventional machining category, that is electric discharge machining. The erosive effect of electric discharge was first noted in 1770 by English physicist Joseph Priestley. Friends, this electric discharge machine is also known as spark machining, spark erosion and burning process. This process uses electrical energy to cut the material and give a desired shape to the workpiece. So friends, let's see in detail how the process works. Let's see content quickly what we will cover in this video session. First, working principle. Second, equipment. Third, working process. Fourth, advantage. Sixth, disadvantage, and last one is the application of electric discharge machining. The working of EDM machine is very simple and old technique in which two electrical terminals with DC supply is separated with a little gap, and gap is filled with dielectric medium, and electron could jump from positive terminal to negative terminals, producing an intensive arc. The temperature of this arc is sufficient enough for removing material from the workpiece. So let's see which equipments are used in electric discharge machining, that is DC power source, tool and tool holder, dielectric fluid, flushing nozzle, filter, pump and feed mechanism. These are the main equipments which is used in electric discharge machining. So let's understand the application of each equipment one by one. See the DC power source. It used impulse generator for the production of successive uniform spark. It's a heart of EDM machine. Friends, it is called heart of EDM machine because it's a generator without which we cannot supply the power. The next is tool and tool cutter. Tool's end point is the replica of the desired shape to be achieved on the workpiece. Tool is generally made of brass, copper, tungsten copper, tellurium copper, graphite materials. Tool material determine the rate of metal removal and accuracy. The metal removal rate MRR and accuracy of the machining is depend on the tool material also. Tool holders are usually electromagnetic type. This facilitates start of cutting and flushing of metal swap. Next, see dielectric fluid. It is the medium which conveys spark from cathode to anode. The medium which gets ionized and deionized are best dielectric fluids. Any inflammable fluid is a good dielectric like kerosene, turpentine, paraffin oil, petrol, transformer oil, diesel, spirit can be used as a dielectric fluid. The next, the function of dielectric fluid. Friends, the dielectric fluid play the very important role during the machining. The function of it is to convey the spark from tool to workpiece, to carry away the material removed during operation, to keep the workpiece and tool cool. Next is filter. Filter are used to remove metallic particle from the circulating dielectric. Second, pump. The pumps are used to circulate dielectric fluid. Next is feed mechanism. Feed mechanism is used to provide feed to the tool. So gap between workpiece and tool can be maintained throughout the process. So let's see first the construction of electric discharge machining. The EDM machine usually of vertical C type of construction as shown in the diagram. Its various parts being base, column, head and table. The head which supports the servo control tool is mounted on the column and other column is fixed to the base. The table is mounted on the base and has a dielectric tank over it. The workpiece are mounted on the table with magnetic vise, chucks and fixtures. Let's see working process of electrical discharge machining. As shown in diagram, the workpiece is set on the table and the table is set in tank. Both is fully immersed in the dielectric fluid. The tool of desired shape is fed from the top side of the workpiece. It is made of graphite or copper. The workpiece electrode connected with the positive terminal and act as an anode, and tool electrode connected with the negative terminal and act as a cathode. The electrical circuit contains a variable resistance and a capacitance. The voltage is applied by DC supply source. A suitable gap as a spark gap between tool and workpiece is maintained. A suitable voltage is applied. A strong electrostatic field is developed across the two electrodes. As a result, electrons start from the cathode towards the anode. This is called cold emission or field emission. When electrode and workpiece come close, then spark at the temperature of 10,000 degrees centigrade are emitted with the melt and vaporize the spot in the metal. To maintain the gap between workpiece and tool electrodes, continuous feed is provided from the top. For that, a feed mechanism is provided. In this process, the electrical fluid can be reused, as all chips and debris coming after operation will be filtered with filters. Friends, let's see the advantages of the electrical discharge machining. The first one is no complicated fixtures are required for holding the job. Even very thin job can be machined to desired dimension and shape. Second, it can be used to machine very hard materials like superalloys. Third, carbide materials can be machined by this process. Fourth, as the tool and workpiece are not in contact, so does not tool wear fast. Fifth, surface finish obtained by this process is very good. Sixth, finish up to 0.4 micron can be achieved on steel. Seventh, the tolerance up to 0.05 micron can be held. 8. Time of machining is less than the conventional machining processes. So friends, these all are the advantages of the electrical discharge machining, and that's very much important. So friends, as per the several advantages, many disadvantages also. First one is the mechanical property of the certain materials may be disturbed because of the high temperature. Second, the power consumption is very high. Third, sharp corners cannot be produced. Fourth, workpiece metal must be an electrical conductor. Then and only then machining can be possible. If workpiece material or tool material is not electrical conductor, the current will not pass. Fifth, some material may be cracked when the process is completed because of the change in temperature. Sixth, material removal rate is low. So these are the disadvantages of the electrical discharge machining. So friends, let's see the application of electrical discharge machining. There are several applications. The first one is complicated profile tools can be manufactured. We can easily manufacture complicated profile tools or special tools. Second, used for making stamping tool, wire drawing, extrusion die, header die, forging die, intricate mold cavity, etc. Third one is for making of exotic materials used in aerospace industry like hard carbide. Fourth, for making the holes of nozzle. Yes, this process is also used to prepare a holes in nozzle. So these are the several applications of the electrical discharge machining. So these are the some evolution questions. Attempt the mind twister question attached through the link in the description box. So that's it from this session, and see you in the next video with some more learning topics. Till keep learning, keep growing. Thank you.